Hallo.
Hallo. Je kan ook nog dit balkje weghalen hè, als je hier steekt. Lint altijd weg, alleen tabbladen.
Ah, dat ik die...
Ja, daar is lint,
Ja,
hè?
die doe ik zo meteen.
Going to wait a few more minutes to give everybody the opportunity to join. Good. Okay, let's start. I think we've given everybody enough time to join the session. So welcome everybody. My name is Dirk Krol. I'm the Executive Director of Water Europe. And it's a pleasure to open this joint webinar co-organized by Water Europe's expert group on water efficiency and the Boost-in project. Thank you all for joining, and of course, thank you for all the participants in putting this session together. Today's discussion will focus on end of waste in the water sector. I think a very important topic, and the objective is very concrete. It's to share experiences from real applications, to learn from case studies, and to explore how we can move towards a European end of waste network and criteria. At Water Europe, our big ambition and our big strategic objective is always to achieve a water smart society and economy. And circularity or circular water is a core pillar of that vision and one of our key innovation areas. But of course, circularity does not scale without clear regulatory pathways. And end of waste is one of those critical enabling conditions. It determines whether recovered resources from water can actually enter the market as products. And in that sense, it sits exactly at the interface between innovation, regulation, and market uptake. In this context, we see increasing pressure to move from pilots to scale. The technologies exist, but the business cases are unfortunately still emerging slowly. And regulatory uncertainty can slow down this deployment. This is why sharing practical experiences as we do today is really essential. Today's program combines technical insights with strategic discussion, including case studies and a reflection on a potential European end of waste water network. With that, I'll hand over back the word to Rafael Cacheles, who will introduce the perspective of the Water Europe Expert Group and guide us into the substance of this session. Rafael?
Good. Thank you. Thanks for this introduction, Dirk. I'm going to share my screen to try to also to frame the discussion and introduce the topic. 1 second that I put it in. Can you see it now in presentation mode? Hopefully, yes.
Yes.
Good. Okay. So, well, thank you also everyone for attending this webinar on end of waste for circular products in the water sector. This webinar is co-organized between the expert group of water efficiency, reuse, and circularity, and the Boosting project. This collaboration, it's indeed part of the essence of our expert group, which aims to promote those type of synergies, alignment, and interaction. And in this case, one of the opportunities that bring us our participation in the expert groups is to find synergies between different projects which are running in parallel about similar topics. In this case, we have the Boosting project and also the CIRSO projects. Both are projects funded under the same topic of Horizon Europe, dealing with circular economy and water and the water sector. We also have strong collaboration with other actors, and I have to stress the collaboration of Aqua Minerals, also in the organization of this webinar, which has been essential. And yes, I'm going again to the boosting and so projects. These projects are coordination and support actions, meaning that we are not developing new knowledge. What we are doing in our projects is try to overcome the barriers for circular economy in the water sector, and these barriers are of are multifaceted, are of multiple nature, and the boosting project in particular is designed to have different type of activities that address these different barriers. One of the barriers is the lack of harmonized criteria on end of waste for many products, which is, as Turk said, one significant barriers for resource recovery in the water sector. So, one second. Yeah, just to explain a little bit and give you some context of the boosting project, we follow this multidisciplinary approach where we are addressing different types of barriers. From the technology side, we are scouting different innovations and innovators to produce a database and provide them with visibility, because some of the innovations are not well known. So, and this is a barrier for market uptake, with a strong focus on digital solutions. But we also address social barriers, trying to identify which are the perception barriers and produce at regional level roadmaps and action plans. We are working at policy level, producing policy recommendations, and more precisely working with supporting the implementation of risk management plans for water reuse and end of waste criteria, harmonized end of waste criteria. And we are also working at market level with selected innovators that will be supported with business models, mentoring activities, and matchmaking. Yeah, how we do that? Taking into account the vast amount of projects and solutions that we have in the European landscape, we are following a funnel model approach where we are scouting a large number of innovations that we are characterized them and producing a database of at least 200 solutions. But at the same time, we are with different criteria selecting different type of solutions to give like ad hoc and more specific support through social and policy analysis of case studies, through impact assessment, in order to understand better which are the benefits of circular solutions and quantify their impacts. We are producing business models, and last but not least, we are strengthening Water Europe marketplace with more solutions, and also upgrading with a new facility that allows matchmaking between problem owners and innovators. Yeah, we have a consortium of 12 partners. Biosul is the leader, the coordinator, but we also have relevant actors and for example, Water Europe, of course, is leading communication and dissemination. KWB is leading the task of end of waste criteria. We have here with us Christian Remy, researcher of KWB, that will lead one of the sessions. We also have other important actors in Water Europe that you probably know, like Utilities or the KEMA. So it's a strong consortium dealing with this multifaceted nature of barriers in the water sector. Regarding end of waste, what we are doing in boosting is to promote a knowledge exchange through the organization of different webinars. We have already maybe some of you already attended the webinar last year. We organized an in-person workshop in the IWA Resource Recovery Conference of last year in Leeuwarden. And of course, today's webinar is a cornerstone in our strategy, because what we are doing today is to present case studies and real case situations, which in the water sector has been quite challenging, I will say, as my colleagues will share with you, because there are no many experiences of dealing with end-of-waste criteria in the water sector. Well, there are some more in other sectors. So, and that's why it's important for us to create a sort of network, maybe a task force, expert group. This is something now under discussion of to gather experts that want to learn more, that want to exchange their experiences, and align efforts towards more harmonized criteria in terms of end of waste. It's also part of our work in the boosting project to liaise the European Commission and the JRC, and we have already some contacts, and they have participated in our last year webinar, and also the DG Environment was invited to today's webinar, but finally, due to personal reasons, they declined to participate. However, we are following up this contact and have meetings to exchange within the interested partners to remove those barriers. At the end of the boosting project, we will produce a deliverable as other projects on providing guidance and support towards harmonized end of waste criteria. That's it from my side. I have to say that in the expert group, I'm closely supported by the co-leaders Christina Bailot and Tom Arnott, and the mentor Francesco Fatone. And I will also like, as co-leader, to give the floor to Christina Bailot, who is also dealing with end of waste in the CIRSO project. So stop sharing. So Christina, the floor is yours. Maybe you can tell us something about our sister project, CIRSO.
Yes, thank you very much, Raphael, for the nice introduction. As mentioned before by Raphael, the CIRSO project is a sister project to Boostin. Therefore, the ambition of the project is quite similar. And within my very short presentation, I will just focus on this end of waste part of the project that just finished, because compared to the Boostin project in CIRSO, it was just a small task, and we just finished the final deliverables on this topic last month. So this is fresh results then, and what we had a different approach to this end of waste topic in CIRSO. We had two different tasks to do there. So one task was about performing an interview-based study on the state of play of end of waste in different countries. So of course we also had a look at the harmonization on EU level. But first part from our side was to somehow document the current status in different countries. We did this for the countries that you can see here on the screen, so 6 in total. What's uniting all these countries is that they have to deal with fragmented operationalization of this end of waste criteria task, risk management, and quality assurance that is currently at some point in place, but still missing in a harmonized way. And that, of course, the cooperation between different partners is crucial to do. So due to the fact that some of these insights we will also hear in this webinar today, I will not go into detail with regards to this. Second part of our task within CIRSO was a task led by Euro, which was about to provide a policy brief on a so-called roadmap to achieve end of waste criteria on EU level. And I will just pick up some parts of it. And these are just meant to be an input for discussion, not to take the end of today's webinar. So, of course, we have some good approaches right now with the recast wastewater treatment directive that is directly promoting water reuse and recovery of phosphorus. And therefore, it's even more important that we need to have those EU-wide criteria to ensure that those targets of the urban wastewater treatment directive can be met. Some of the obstacles to this topic and to circularity in general were already raised by Raphael and by Dirk in his introductory speech. So we have a lack of public perception on wastewater. recovery. We have an economic barrier for products coming from being recovered from wastewater. And within the project of SOSO, we saw that there might be two approaches to deal with this economic barrier. So one thing would be to have some mandatory minimum of portion of recycled nutrients and fertilized products, for example, or the other thing would be, of course, subsidizing those circular products. But in general, and this is also some outcome of this interview-based study, the legal uncertainty is still a crucial hindering factor for investment in recovery capacities, which might be also hindering for achieving the wastewater treatment directives goals. So some priorities that could come up directly from that would be to get to touch the fertilizing products regulation. Other things would be, of course, to go for this component material criteria to cover more recovery methods than today. We see that there should be some shift towards a risk-based rule and not going for every single component. And finally, we see that at least in the end, mutual recognition among member states could be also an approach when we fail to really achieve harmonized end of waste criteria at European level. So we see that there are some opportunities for action. Therefore, we are happy to have this workshop here and also to have this work done within SOSO. As said, this is work that has been shortly finished, so the final deliverables will be available soon on the SOSO website. And just with this quick insights, I'd like to stop. Thank you very much.
Good. Thank you, Christina. Yeah, maybe we will have a discussion about next steps by the end of the webinar. Maybe, yeah, if you can stay, it will be very helpful for us. Now I would like to give the floor to Alke Lida de Jong to give us a introduction on routes to end of waste as a sort of introduction of the case study that will come later. So yeah, this our two presentations from Christina and my side were meant to be like a introduction to the topic, but yeah, I think Alke will give us like more insights on what end of waste is and why this is a barrier in the water sector. So Alke, the floor is yours. We see your screen perfectly.
Yeah. Hi all,
Yeah.
I'm Alke from Aqua Minerals. We are a shared company of the Dutch drinking water companies and the wastewater boards that are responsible for wastewater treatment. We bring their residuals and recovered resources to the market. I will give you a quick introduction on end of waste before we go to the cases, and the expert can, in the meantime, get an extra cup of coffee. So when we flush down the toilet, we dispose waste. Wastewater is also a waste, which means that a wastewater treatment plant is a waste treatment process. And everything recovered from waste is initially a waste. It can lose its waste status, for example, after processing step, and then become end of waste. And in the Waste Framework Directive, the EU has defined 4 criteria when a material or object becomes end of waste. I will come back to that later. What's important, a waste treatment process can never give byproducts. Byproducts can only evolve from a production process with non-waste inputs, at least according to the common interpretation. Drinking water production is, for example, such a production process. So residuals from drinking water production can actually classify as byproducts. And also the Waste Framework Directive has set criteria when a residual is a byproduct. Big difference between byproduct and end of waste is that the byproduct never has been waste. A byproduct must be ready to bring to the market. If it first needs further processing, like you would have to do with the waste, it's still waste, and then you can only follow the route of the end of waste. In most cases, we want to get rid of the waste status for the recovered resources from the water sector, because a waste status comes with a negative value, often also a bit image. Most companies don't want to deal with waste, and also a need for special permits to produce it, to use it or to process it. Also, it cannot be transported across the borders, except with the time-consuming and also quite expensive waste transport procedure. Waste processing companies that have a permit to process waste are generally more interested in earning a gate fee than in creating a value chain with recovered resources, because this requires effort and it's taking risk. So with a waste label, we're actually stuck with these waste companies, and we won't realize the full financial and sustainability potential of the recovered resources. So in addition to this, secondary materials have to compete with virgin materials when we bring them to the market. And these virgin materials are ahead on money aspects. Recovered resources are mostly more expensive. It's difficult to beat the quality of virgin materials. Virgin materials are established projects. Well, for these recovered materials, we still need to get permissions. We need to realize end of waste. And also we often start with small volumes that makes it really difficult to enter a bulk market. Also, recovered resources are often a little bit different and need adaptation of production processes, logistics. And while they may have a green image for some, but other companies find it a little bit scary to deal with something that is derived from waste. So end of waste is really a necessity if you want to make a chance in this difficult market. Well, based on case law, the EU has formulated 4 criteria in the Waste Framework Directive when a substance is no longer waste. The first 2 criteria, you see them here, they must ensure that the material is actually used. There must be a market and there must be a specific application for which it will be used, or several applications. The third criteria is that the substance must, of course, meet all legal requirements for the application and also for more general things like the REACH registration, and of course also meet the requirements from the buyers. This is not different than for a virgin material, but it's made explicit in the end of waste criteria. The fourth criterion is the most difficult. That's to prove that the use overall causes no harm for human and the environment. And well, for wastewater, we have to deal with wastewater, which can contain all kinds of substances like drug residues, pathogens, microplastics. And there are not so many standards yet on analyzing them, and it makes it quite difficult to fulfill this criteria. What's important, end of waste assessment is always for a specific application. There's no such thing as universal end of waste. So each new application needs an assessment. There are several routes to end of waste. I start on the right. The EU can make an end of waste regulation, like there are already for scrap metals, glass gullets. They're working on plastics and also on aggregates. And the fertilizer product regulation is also actually de facto a end of waste regulation, because if a fertilizer producer gets a CE mark on its EU fertilizer that contains secondary materials, it becomes end of waste. The second route is national end of waste criteria. Member states can also make a national end of waste regulation. In the Netherlands, we are working on end of waste regulation for cellulose, and I will present this case later. The third option is case by case. The competent authorities, they can make a decision about the end of waste byproduct status, or they can give a legal opinion. In every member state, this is different. And end of waste in one country doesn't mean it's end of waste in another country. The fourth option is the self-declaration. This is a relatively unknown route that may not be possible in every member state. In the Netherlands, it's currently promoted also by the government, but it requires some braveness. It means that as a company, you do the assessment yourself along the criteria, and you declare end of waste and you enter the market. But there's always a risk that the inspector might not agree, and then you get a court case, and in the end, it's the judge that makes the decision. At Aquaminerals, we use self-declaration, for example, for liquid CO2. My colleague Emma will present that case, and for calcite from drinking water. And then the last category, that's an interesting one. In some countries, there are regulations, for example, for building materials that exclude materials from the waste regulations and put specific rules in place. So it doesn't matter anymore if it's waste or end of waste. If the regulation allows you to use the material, you can use it. And another thing we see is that recovered resources are used without explicitly addressing the end of waste criteria. Sometimes these are old applications from the time before the Waste Framework Directive, or sometimes just no questions asked, no dossier made, and it's okay. So this for a quick introduction. If you have any questions, you can post them now.
Yeah. Any question? Yeah. If anyone has a question, you can write in the chat or just raise your hand. I think it's allowed to the audience to make questions, right? Like, I mean, like speaking. Yeah.
We can allow, yeah, to speak.
Okay. Yeah. If not, anyway, we will have Alke with us in the case studies presentation. I think, yeah. Oh, no. Yeah,
no, you should write in the chat.
You should write in the chat the questions. Okay. Yeah. So I think, yeah, thank you, Alke, for this very interesting introduction to the topic. As yeah, this is yeah, quite essential also to substantiate what is coming now, which are the experiences. And yeah, I would like to call Sarah Stjernström from Easy Mining to present their case study on end of waste for ash to phos products. So Sarah, yeah, we can see your screen. Thank you. The floor is yours.
Thank you so much. Hi, good afternoon. My name is Sarah Stjernström. I'm in sunny Uppsala in Sweden, and I work at Easy Mining, which is an innovation company that is fully owned by Ragn-Sells, which is a waste management company. I have been working within the sector of recycling for over 10 years now, and the waste has for 10 years been one of my favorite topics. So this is a great place to be today, I think. Easy Mining is a company that develop, design and build on patented processes that we have invented. And it's focusing on nutrient recycling. And obviously a lot of focus is that the wastewater treatment plants is our resource plants. And that's where we will get these great raw materials that we can build our recycling techniques on. We are over 80 employees right now. And we have been founded in 2007. And have now built up offices outside Sweden as well, as you can see. We are focusing on both all the macronutrients. So we have Aqua to N, which is a technique to recycle nitrogen. We have ash to phos, which I will focus on in this presentation. Here we are building 2 plants at the moment, one in Germany and one in Sweden. The first plant is in Germany to be up and running next year, and then Sweden will come approximately 2 years later. And both of these plants will handle 30,000 tons of sewage sludge ash. So sewage ash is a waste that is also the main raw material going into these recycling processes, and that needs to, on the other hand, produce products, which also then needs end of waste, and we'll come back to that. We will produce a calcium phosphate, which is the main product, and that's a very pure product that can be used as a feed phosphate or a fertilizer. We also have ash to salt, which I will not go into details here, but it's already a plant up and running in Stockholm in Sweden. And here recycling of salts from fly ash from household waste is in focus. And obviously the salts here as well have in the waste status to be sold into industrial processes. These are just pictures of the plants, what it will look like in Germany soon. And also in Sweden, it's already a building that we are designing for to the right. Okay, so I'll continue with ash to phos. This is just to give you the process. As I said, we use ash from sewage sludge from the wastewater treatment plants. It's incinerated into an ash, and we have a lot of detoxification happening then, where organic pollutants, pharmaceuticals, etc., will disappear, and we will have to handle all the heavy metals. We also use an acid and lime in this process, and the best thing I think with this process as an ecotoxicologist is that it has a great detoxification step. So the heavy metals will be concentrated, and we will get materials which comes out that can be classified as products. We have iron chloride that can go back to the wastewater treatment plants. We have two different types of aluminium products that we will produce. In Germany, we will have sodium aluminate, and in Sweden, aluminum hydroxide. And then the RevoCap is the recycled phosphorus. We also have a sand fracture, which I will not talk about today, but I don't see initially that will be classified as a product because it doesn't have anything in REACH, which would find its sameness, which you need if you don't register yourself, of course. And then I wanted to show you this picture, and it's a similar one that you already saw. I mean, end of waste options. You had 5 in the picture, I think. I only show 3 here. And what we need to do is the case by, I call it case by case, because we don't have an EU common end of waste criteria for these products, and we don't have national in Sweden or even Germany. These products doesn't have this national end of waste criteria. So we have to do the case by case, and that was called the self-declaration in the previous presentation. So it's the same we're talking about, and it's also the same legislation here. We're talking about the criteria. What I would like to focus, because I thought about this before, is more how to reach the product requirements rather than the ceasing to be a waste, because I think we focus too much on that, and for our sake at least, the difficulties and hindrances are more in the later stages, which is the products regulations. And I will also mention a few words here that I will show you soon, and I don't know if everyone is familiar with those. So a monoconstituent substance is something you have in REACH, and this is when you have to show that your substance is at least containing 80% of what you're talking about. And the 20% has to be predefined accepted impurities for it to be classified as a monoconstituent substance to fulfill the products legislation, and in this case then REACH. Then we also talk about sameness, and sameness is the criteria that describes the identity of the substance. And for that we have the substance identity profiles, SIP reports, which are already the registered products, a consortium that have gone together to register a substance in REACH. We have to also look at them to fulfill them. At least if we want to use the exemption in REACH, we don't have to register it again, it's already there. That's the kind of one of the points, I think, with end of waste. You can, of course, do end of waste and then register your thing in REACH in the end, but this is at least what we're initially going for, the exemption. And this is just a summary, maybe a bit all over the place here. And you can, of course, I can share the slides, so no one has to write anything down here. But I wanted to just sum it up. So you have the recovered products. If you start with RevoCap, it will be a monoconstituent substance. It will replace phosphate rock, an organic fertilizer, or a feed phosphate. And we have it approved now as a feed or as an organic fertilizer, sorry, within the EU legislation. So these two paths are open. Of course, we have a demand in the market for these products. I don't think I even have to mention that. And we also have quite clear quality demands in these legislations already in place. So that's not either a problem from like ceasing to be a waste. It's not a problem here. It's quite clear what you need to fulfill, both from physical and chemical properties. When it comes to animal nutrition, we fulfill the feed quality parts. However, as you can see, it's a red box there. The feed legislation is close to everything recycled from waste, or at least wastewater. So this is a huge problem for us. And then, of course, it's very difficult to do end of waste fully. And we cannot reach that market right now. So we're working on opening the feed legislation within EU. We also make iron chloride and 2 different aluminium products, and those will also be monoconstituent substances. And they will reach the wastewater treatment plants is the goal. And here, of course, we have standards for what quality you need for the type 1, type 2, type 3, for example, for the iron chloride used as a coagulant. For example, aluminium hydroxide can be used as a raw material to make a coagulant, and those are also quite clear demands. And here we can use the exemption based on the SIP report. But there are some questions here that I would like to raise. For example, you can see in the green box to the right for the iron and aluminium that if you add chemicals in the process, not all of the thing you have recycled is based on a waste. So for example, you add a chemical, if that follows your process, it's not sure that you can use the exemption. You might need to go into the consortium and be part of the SIP report as a registrant instead. And that's something we're looking into. So I don't have the answer what will happen yet, but we might need to go that path, take that path. And I just wanted to give you an example of the RevoCap in this picture, how we kind of go through this very shortly. I did now the points. So on the one side, you have the ceasing of the waste and how we fulfill the waste framework, how we show that the RevoCap will fulfill those parts as a fertilizer. It has an existing market, fulfills all the quality demands, etc., etc. And it will, of course, not. It's easy here because you have all these quality demands, so you can say that it will not lead to adverse environmental or human health effects. So that's positive. On the other side, fulfilling REACH, I think, yes, we have the SIP report. We can show that we fulfill it with the cost number and everything. We have created safety data sheets and so on. We have no hazardous or special restrictions, but we cannot do the last part, which is also product registration, since we haven't started the production yet. So that will be done as a last step. And then, of course, all the certifications we need to do. So there's a lot of things more we need to do for sure. And last slide, I wanted to bring up these 4 points, which is the uncertainties or the main things I'm thinking about, like hindrances or things I would like to discuss more. And one thing is very clear, that it's the SIP reports that you need to fulfill to use the exemption or to use another registration. It's often unclear, and especially for recycled products, how do you analyze and measure to show sameness? That can be very tricky, we have realized, to find the right methods that are okay. Like sometimes you might need to go beyond the standardized methods to kind of do this. So you need to prepare that you need to put some time and effort into this. Maybe you need to go to a university or go beyond to find these solutions. And it's not super easy especially not we have seen for the aluminium and the iron products. If you, as I mentioned, if you add chemicals to your process, which are virgin, you might need to do a registration or be part of a consortium, a registration in place. You cannot use the exemption. So you also need to think about that. Because everything that you have in the end has to come from the waste. Otherwise, you cannot use the exemption. That's how I've learned. Another thing which also has been mentioned in the self-declarations, or I called it case by case, is that authorities don't approve the end of waste documentation. You might end up in court, as was mentioned, if you don't agree. But this creates a lot of uncertainties, and is one of the main reasons why I think we need these criteria clearly, because at any time you can get an inspection, and then you can get like, oh, we don't agree with you, and then you might need to go to court, and you have to maybe even stop the production. What do I know? So that creates a lot of uncertainties, which I think is not okay. So this would be actually my point. This should be my point one. Like this for self-declarations or how we solve this, I don't know. Maybe I've misunderstood something, but I think this is a huge uncertainty. And then obviously the feed legislation is very unclear and kind of bans on origin instead of focusing on quality, which makes it very difficult to recycle anything and do end of waste with feed stuff. And that's also very sad that we will not have circular feed materials if we don't look into this. And this was my last slide. So if anyone has any questions, otherwise, thank you.
Good. Yeah, thanks a lot, Sarah. Yeah, if anyone has any question, feel free to put them in the chat. Yeah, there is indeed a question about heavy metals. Yeah, the question is if heavy metals are removed or not. I guess you're working with the ashes. I don't know, how do you address these issues if they are up to a level which is accepted with the criteria you are following, or this is something you need to take additional action to be treated and removed? How do you address this issue of heavy metals?
Yes, of course. It's a good question. I mean, there's a lot of heavy metals in the sewage sludge ash. Everything gets up concentrated. So that's why it's a good raw material. It contains like 9% phosphorus. But in ash to phos, we use chemical recycling. So we recycle pure products that fulfill all the standards and legal parts, and then we take away the heavy metals into a heavy metal cake, and that is landfill. So that will be classified as hazardous waste. So the heavy metals will be concentrated, classified as hazardous waste, and go to landfilling. And the products will be pure. So that's like the beauty with the ash to phos process, I would say.
Good, thank you. I think it's very clear. There is another question from the audience. How can easy mining's technology be integrated into existing industrial ash or metal recovery process in the Nordic region?
I think the question is in the Nordic region, if you mean that there's no, for example, in the Nordic countries, there's no real sewage sludge incineration today. That's true. If that's what you mean by the question, I can say that first years with the ash to phos in Helsingborg in Sweden, we will have to take ashes from Germany probably. But there is one municipality in Sweden that has applied for a permit to start incinerating ashes, sewage sludge. So that might be an option for us. Otherwise, we think there will be so much ashes that need recycling with the German legislation coming into force in 2029 that we think that will not be a problem or risk for us.
Okay, thank you. There's another question. What is the timeline for the registration and fertilizer approval? Regarding that, the plant will be ready in 2027. So yeah.
Yes,
timeline for registration. Yeah.
So we have in the German plant, we will start it in the middle of next year, as it looks like right now. So we will start very soon with all the things that we need to do. We have already documented as much as possible for all the products coming out. But we will need to, as soon as we have the plant up and running, we will also have to take all the samples again to put into the report. But it's for end of waste, as I've understood it, you will get an inspection whenever they feel like it. So it's not certain that it will be the first week of the plant is up and running, or it can be whenever. But sure, everything has to be documented and in place as soon as we start up. And obviously we need the good quality assurance program, so we sample everything within the value chain all the time to fulfill this.
Okay, thank you, Sarah. Your presentation is so interesting that it's raising interest also in the audience. Yeah, there's also a question about the self-declaration that you mentioned. Yeah, how this is assessed by local authorities, and the
Yeah, I
audience is
can take
asking.
that one. It's from
Yeah.
Mark Smith. I think I know him.
Okay, okay.
That depends. I have had a couple of self-declarations assessed by law enforcement, and they may just have a quick look at your dossier, say, it looks okay, fine. They may also dive into it, look into the details, and then conclude, we don't know enough. And they might involve other experts. There's not so much experience with it yet, at least in the Netherlands.
Okay, good. I'm taking a last question because we have to move on with the program. But this is also an interesting question. When we are having small volumes of waste streams, it's often difficult to build a business case and therefore keep circularity as a profitable business. How do you see this, Sarah? It's yeah. How do you deal with it when you have small volumes? I don't know if this was a problem in your case.
Yes, it's a very important question for recycling in general, that you need probably to build, at least if you look at Ashtafos, it's quite big units, central units. You have maybe 300,000 tons of sewage that will become 30,000 tons of incinerated ash and then going to us. So, and we have said that this is maybe the smallest units we can go for to have a good business case. But of course, if you do pyrolysis or some other technologies, you might definitely need, you can go smaller. And I think we need all of these different technologies, because like in Sweden, it's a very long country and we cannot transport sewage for sure, and maybe ashes a bit further, but we will need a lot of different technologies. And another thing I think that we don't talk about so much is the waste transport legislation. It's horrible to try to collect raw material cross-border. But that's also something that the EU, I think, needs to recognize, that if we're going for circular economy, we need to look at waste as a raw material, if we can show that it can be used as it. And then that needs to be simplified, because today that is the worst legislation I know for sure.
Yeah.
Okay, it's not at all a good answer here, but
no. But thank you. We are here to learn from the experience and also from your challenges. This was quite interesting, also to see the great potential on nutrient recovery and all these regulatory barriers. So we are moving forward with the program. Besides nutrients, there are also other materials which are valuable in our wastewaters and also dealing with problems with end of waste. So I would like to invite Alke again to tell us about their case study on recovery of cellulose. So Alke, the floor is yours.
Yeah, thank you. I already introduced myself and Aqua Minerals. I also would like to introduce to you the Energy and Resource Factory, which is a network organization of the Dutch water boards, where they work together on resource recovery. While they focus mainly on the technology side, we focus on the market side, and we have a very strong cooperation. That's also the reason there's a lot going on in the Netherlands on resource recovery from wastewater, and the reason that we have 2 cases today from the Netherlands. Actually, my colleague Emma has done most of the work for the end of waste regulation on cellulose, but she's presenting already CO2, so I got the honor to Take this one. We have cellulose recovery on a couple of wastewater treatment plants, and we expect it to grow in the coming years because it makes the capacity of the wastewater treatment larger, so it's quite an advantage. We don't have many end of waste regulations in the Netherlands yet, only one actually on recycling aggregates. And already in 2015, the Dutch water boards that are very active on resource recovery, they asked, please could we get the end of waste regulation for all our recovered materials? And then the responsible minister said, oh, no, that's one bridge too far, not too fast. Let's first gain some experience with a end of waste ruling for struvite. And maybe they were right that we were going too fast because it took 7 years to get this end of waste ruling. And the reason was mainly that the national government still needed to develop a vision and methods how to judge the safety of recovered materials. But well, in 2021, they announced that they would make an end of waste regulation for cellulose and one for struvite. And the expectation then was, well, it will take 2 or 3 years. Oh man, we have been so optimistic because it's 2026 now and we are not ready yet. The process, well, the Dutch, they love co-creation. So this kind of co-creation process involved are the Ministry of Infrastructure and Water Management and their executive body, Rijkswaterstaat. We have on board RIVM, the National Environmental Institution, of course, the Dutch water authorities and the Energy and Resource Factory, Aqua Minerals and Salvation, a technology provider that has developed a technology to make nice, clean cellulose products out of the recovered cellulose. We talked already a lot about cellulose. What is it actually? Well, in the effluent, there's just a lot of toilet paper. And on the sewage treatment plants, you always have a core sieve that takes out the regular screenings like these yellow towels, tampons, mobile phones, yeah, whatever people throw in the toilet. And then you can also install a fine sieve, and that's what we are talking about to recover the cellulose. It's called fine screenings, and they contain about 50% of cellulose. The idea is that this raw cellulose is further processed either by the salvation process, which makes this clean cellulose products. You see here some pellets, but they also make a kind of fluff. It can be further hygienized at the wastewater treatment plant itself to get rid of some pathogens and then bring it to customers. Or this treatment and hygienization could be part of the production process of the customer. For example, if they have a production process with high temperature, pressure, also the pathogens will be killed. We try to get the end of waste as soon as possible in this whole value chain, namely on the raw cellulose recovered on the wastewater treatment plant. If it's not possible, we move up a little bit in this value chain. The first question was, for which applications are we going to make an end of waste regulation? Because end of waste is use specific. And there are a lot of possible uses of this recovered cellulose on the way. But the ministry asked us to make a choice. They said, we are not going to put everything aside, you have to make a choice. So we choose composite, sheet materials, as drainage embedded in asphalt, and as a raw material for the production of glucose and fatty acids. The consequence of this is that all other applications will be outside of this regulation and they will still need case-by-case decisions or self-declarations or whatever. We did the same as Sarah just told. Per application, we looked for relevant regulations, but I won't go deeper onto that. And we looked into REACH, and as a natural polymer, cellulose is exempted for REACH. So this was rather easy for us. Then important piece of our work is the fourth end of waste criteria, is to use safe for human and the environment. Well, it's clear we cannot measure everything because there are thousands of different contaminants that could be in wastewater and also in the cellulose. So we had to make choices. Heavy metals we had already measured in another project. Pathogens were also already measured. Well, they are present, so the material needs hygienization, no question. We focused on pharmaceuticals, pesticides, and substances of very high concern. And the approach that we choose is we made a list of indicator substances, a relatively short list that would represent a kind of worst case what can be in the cellulose. And we did bioassays to measure the hormones, because they cannot very well be measured by chemical analysis, and to measure the effect of all these contaminants together. We based this selection of indicators on whether we know it's in the effluent. I mean, it makes more sense to try to measure something that you know is inside than something that may be inside. If it could be in the cellulose, we selected mainly chemicals that have a strong affinity with organic matter. We selected based on high ecotoxicity, persistence, and we made sure we had a good representation of different types of pesticides, pharmaceuticals, so all the groups inside. And last but not least, we selected based on whether the laboratory could measure it. They weren't able to measure some of the substances that we would like to measure. We replaced them by others. And also there are a couple of substances that we just couldn't measure. We ended up with a list with about 50 substances or substance groups so that we were going to measure. We had a lot of discussion on this indicator list. Should we measure all the substances from the population? How many indicators is enough? What should we do with these substances that the laboratory cannot measure? And in the end, the ministry approved the list, but I must say there are still doubts, so maybe it will turn back to us later in the process. A difficult thing for us was to find a laboratory that could do the job, because most laboratories are production laboratory, and this is a specialty. Different than many people think, you cannot just go with a new substance to a laboratory and say, measure this and this and this. No, their methods are based on well-known materials. And if you use this method for a different material, the results might not be trustable. Maybe they don't measure all of the contaminant that's inside. So we needed a laboratory that would validate the matrix, determine the recovery rates, look into these detection limits, and also carefully document everything that they do, which a laboratory also normally doesn't need to do. And what we learned is that you have to be very clear in advance what you need from a laboratory. They don't automatically do what you need, and they also don't know what you need. And we had a lot of back and forth, like I told already, what can be measured, what not, what can we place. Maybe Emma sent 10 times this list back and forth to the lab. Yeah. In the meantime, we started the sampling. We sampled raw cellulose from 3 wastewater treatment plants, 3 rounds through the year to catch also the seasonal fluctuations. And we made mixed samples from 4 weekdays in a row. And here you see a close-up of the material. You see it's quite rough and inhomogeneous. And we put it in the freezer to be able to analyze it in one batch. Also, in the meantime, the National Environmental Institution, they worked on trigger values. Well, what's a trigger value? A trigger value is a safe concentration in a material, in this case, in the cellulose. And the idea is, if we have the results of our analysis, and when they're lower than the trigger value, we are fine. We don't need any more further risk assessment. So how did they make these trigger values? With the literature search for the most critical, most toxic chemicals for human, soil, and water. And then they looked for called the PNEC. And we made together critical use scenarios to know in several critical applications how much cellulose would maybe leach to water, how much cellulose would be put on the soil, and how much may be ingested. And this resulted in these trigger values. And like you see, the trigger value for water is much lower than for soil and human contact. And this is simply because water organisms are more sensitive. End of last year, we got the results of the analysis, and alas, but not unexpected, some substances were measured in concentrations above trigger values. So we are not ready yet. And we run into a problem as well that there are for many substances, the detection limits turned out to be higher than the trigger values. So actually, we don't know if they're above the trigger value or below the trigger value. So now the National Environmental Institution, they will advise how to proceed. It may be that we will reevaluate these trigger value scenarios because now we use really worst versus case applications, and what we aim for in the end of waste regulation are different applications. So we might get a little bit higher trigger values to evaluate. We might do some risk calculations with the substances that were measured above trigger values, and we may need an extra round of analyzing. We're just waiting for their advice now. And then, yeah, in the end, it may be that we are all fine then, or we may need to exclude or to limit certain applications. What we're also working on is quality assurance. A National End of Waste Regulation requires that there is a conformity assessment procedure. So the company that produces the end of waste material, they will need to give a conformity declaration, and they need to be audited by an external body. Our national, normalization institution, then they will develop a scheme. I'm a little bit worried about this because it will potentially lead to high yearly cost for the wastewater treatment plants and a lot of complexity. But we are also part of the process, so we try to make it as lean and simple as possible while still ensuring, of course, a good quality from the materials that we will bring to the market. I come to my last sheet, the lessons learned. Well, I can say until now it was a very rich learning experience for all parties, and also very time consuming and expensive. I mean, the amount of hours we put in it is really insane. And also the analysis weren't cheap. We had a budget of about 80,000 euros. And then not to speak of the cost of the normalization institution and environmental institution that are paid by the ministry. What also an important lesson I mentioned already, that it can be so difficult to find a laboratory, and that you need to be you need to know something about analysis before you can engage a lab, because you need to tell them in detail what you want and what you need. What bothered us a lot is the uncertainty. When is it enough? How many substances? What is a low enough detection limit? What are acceptable risks? And I think if we want to move forward with this kind of dossiers, we need more guidance on it, preferably from the side of the European Union, so that we are doing it all the same in all member states. Another thing that we learned is that the regulation is actually quite inflexible. We are now putting 4 applications inside, but we know already we are going to do different things because it's a relatively new material, so the market and the product is still developing. So with what we know now, I would say cellulose is just too small yet and too novel for national end of waste regulation. I would say this kind of regulations are better fit with established material, established applications, and also substantial volumes. So when we start a new end of waste for new material, we will probably choose self-declaration or a case-by-case decision or a combination of such. So thanks. That's what we learned.
Good.
Do we have questions?
Good. Thank you. Thanks a lot, Ake. Any question in the room? You can write it in the chat as previously. Any comment? Okay. Yeah, there is a comment from Christian. You can yeah, please do it yourself.
I take the opportunity to put my question directly. Thank you, Rafa.
Yeah.
Thank you, Alke. Very interesting. So I see that you put a lot of efforts and money in trying to set up a national regulation. My question, the companies, I mean Salvation or any other company, when they have a case by case thing, they also need to follow this route. I mean, checking laboratories, checking parameters, checking whatever toxicity levels. Do you see any chance that a company on itself can go this road and can really be sure with this dossier, and then at the end that they are sure that nobody comes and challenges it? So I'm a bit afraid that this route is not feasible at all for any smaller company.
Yeah, it's a difficult route, and I think I hope with it that we have made some steps and that we also can help others. As I agree, for just the small startup companies, this is just not realistic. We could do it because we represent the whole sector, yeah, that together has deep pockets. But yeah, but I also hope when we are gaining more and more experience with resources from wastewater, which contaminants can be there, how we analyze it, so we can build on that and build and build and build, and in the end, also the small companies can make their assessments. That's at least my hope. And not every substance is that difficult. Emma is going to present the next case, and that turned out to be well, much easier in terms of contaminants.
Good. Okay, thank you. If there are no further questions, we can move on to the next case. It will be presented by Eva van Dobben, who will share with us the experience of aqua minerals in with the recovery of carbon dioxide and end of waste. So, Emma,
Yes.
ears, the floor is yours.
Yes, thank you very much. Yeah, so my colleague Alkelida de Jong just talked about cellulose and also the difficulties with it. Now I have a happy story, which is about a self-assessment for CO2. So I'm gonna share my screen. I heard it's maybe not full screen, but hopefully big enough to read it well. So the self-assessment for CO2. Why did we do a self-assessment? Well, we trusted that we would not find large risks for human health or the environment, mainly due to the CO2 production process, which I will tell in a second. So that's why we trusted we could do a self-assessment. The CO2 production process, well, when you have wastewater treatment, you get sewage sludge. After it's pasteurized, you can digest it in a building like this. And by that, you will release biogas. From this biogas, you want to split a stream which is methane and a stream which is CO2. That's then the extra that you get out of it. You have different filters. So many of those filters, they already clean the biogas. So it's in many different steps. The last step is a membrane separation. And there you see in this picture next to it that the methane is still in this pipeline, while only the CO2 can get out and no other substances can get out of it. So after that, you have CO2. And you want to purify it and make it liquid. So there are different filter steps as well. And in the end, you have in the storage tank, you have a very pure liquid CO2, which is often like 99.99%. Where do you want to use the CO2 for? We want to use it for greenhouses, so it can enhance the growth. And as dry ice for laser cleaning. So instead of using sand, you can also use CO2. It makes less of a mess. And with greenhouses, we see it as a technical application, technical grade, so not the food grade, because the CO2 is not in direct contact with the fruits. It's not getting direct into the fruits. Well, there's a whole list of technical grades that you can think of. So the two I just mentioned, but we already keep in mind that there might be more in the future. So there's a long list, and we think that if this self-assessment works for greenhouses, that it also works for many of the other technical grades, because they often are in the same kind of, they have similar risks. They are in the same environments, very controlled environments within closed systems. Their environmental exposure is low. Maybe some contact with the air is possible. And they're also in the same shape. You know, CO2 can be in gas or liquid or solid. But when it's liquid or solid, it's very cold. This is the dry ice. And it will rapidly convert to gas. And for worker risks, when they follow the safety data sheet, well, you know, you have, of course, ways you have to use, ways to work with CO2, but then we think worker risks are fine, and the consumer risk, there's no direct contact with the consumer. So with many of those different uses, they're actually very similar risks. So if you look at one, it's a high chance that the other uses are also safe. So the end of waste criteria, Alke already mentioned them, and are mainly focusing on the fourth, so no overall adverse environmental or human health impacts. The environmental impact, well, we're talking about very pure CO2. So it's mainly what is in this 0.01% that is not CO2. Well, I went on collecting information. I contacted the filter installation company, and it was really useful because they could tell me a lot about the production process, but also about what they expected for contaminants to still be in CO2 or not. I also looked at the literature and at previous projects, mainly cellulose, which Alkelida just talked about. Well, the approach was first the question which microorganisms and chemicals can be in CO2, and then what regulations are there for the uses, and do the analysis results comply with these regulations? And can we find anything else, any other risks that we have to look at? And then we can conclude if it's end of waste or not. So we start with microorganisms. Because this liquid CO2, it had many, many filters that it went through. But it started with being sewage influent, and then being sludge, and then being biogas. So what traveled through those different phases and is still in the CO2? Well, theoretically, by talking to the filter installation company and looking at literature with studies that used the same type of filters, they said no microorganisms can go through these filter steps. So they should be out of the CO2. So that's the theory. And then we're still going to test it. But in theory, we don't find them. Then the chemical contaminants. So what can be traveling from the sludge and come eventually into the liquid CO2? I looked at studies for biogas and CO2, and also to this cellulose and the waste project that my colleague talked about. So there, we had already a list of indicator substances that could maybe travel through and get into the CO2. After a conversation again with the filter installation company, they basically said, like, all those filters, they filter out so many of the contaminants, actually nothing can go through that we're really worried about. So for example, sulfur compounds that can be found in CO2 should not be in there anymore, or at least in very, very tiny amounts. And also many of the harmful contaminants that we're worried about, like the substances of very high concern, or the pesticides, or some pharmaceutical residues, that were also of concern for the other projects, the cellulose project. In theory, we would not expect to find them back. Then the regulations. So this is actually also the third end of waste criteria. I see that I have it the other way around or not. I duplicated the slides and I should have deleted another one. But there are no regulations for technical grade. So there are only customer requirements. So in literature, we find some things. So the customer requirements, they're the fertilization law. So this is a wish of the customer. It's not a regulation in this case. And some limits on CO2 and other substances like total sulfur. In the literature, I went really looking for, are there any concentrations, in this case in a greenhouse, that do not, that you don't want to have above a certain concentration. And I could only find a few substances that were mentioned to not, to have a maximum concentration in greenhouses. And there was also a legal opinion for CO2, where the environmental agency, they listed a few limitations for certain values. And we also took those into account. Then we did the analysis, and actually it went very easy. So the laboratory knew the matrix, was very, very, very familiar with CO2. They could measure many contaminants. So what we measured was, we wanted to have the microorganisms checked if they were safe, and also see if we met the customer requirements. And then we did a screening. So we did a screening for the substance of very high concern, medicine, pesticides. It was a large database, and I checked if the database made sense for us. So if the things that we wanted to measure were in this database, and then we did a broad screening. And the CO2, they came from 2 sewage treatment plants. Well, the results were very positive. So there were no organisms found, microorganisms. The customer requirements were met. The literature, where I found no effect concentrations, we were way below those concentrations. And we also did not find anything that seemed at risk in the screening. So we did not need to do a further risk assessment. We did we had an expert that checked our documents. So he looked at, did we look at this, the regulations correctly? Did we do everything that was needed? And the answer was yes. So it was very nice for us to have it confirmed and have an external party looking at the document. So the conclusion is it's end of waste and for greenhouse use and for dry ice. The lessons learned. It took a few months, so it was very fast. We did not have big problems along the way, and I think what made it very easy in this case is that the production process was very kind of solid. So with so many filters, all contaminants were already filtered out, so it was as well theoretically very strong story, and we backed it up with the measurements we did that confirmed the theory. And I think also for some other products, it might be very easy relatively. For example, if you have a source that doesn't have so many contaminants, or you really well know the contaminants already, or when the use is very safe, so you don't have so many risks for environment. So I think there are, possible scenarios, like multiple scenarios, in which case the self-assessment can be quite an easy ride. So now in the future, we want to check upon the quality, so we keep measuring. We want to have new production locations, and for those, we also, of course, do the measurements first. We may want to go to food grade. We already did some testing. For example, if you wanted some CO2 in your water, that might be very nice application. Yeah, it seems that this is also a possible road for us. And I think it's very important that the self-assessment is a living document. So when you add new uses, new locations, or something happened to the production, you need to measure again and also see, like, do I have all the regulations in check? Do I need to measure some new things? Do we have new knowledge that we can apply? So it's a living document, but as you see, it is possible. There are also projects where it's easier. So thank you very much. And I'm wondering if there are questions.
Thank you. Thanks a lot, Emma, for your very clear presentation. Yeah, you are very welcome to share your questions in the chat. Yeah, if any, I do have a question. I was yeah, and Christian has another question. So Christian, you first go ahead. You can take advantage of your role of
I have
speaker to make a direct question.
Yeah. Thank you, Emma. Very nice case, and I'm happy that to see that self-assessment can work. My question: do you expect? So there was no authority involved in this process because you only did it on yourself. That's what I understand. Do you expect any authority to come and challenge your self-assessment, or do you feel safe with your document?
I don't expect them to come and check, and I do feel safe.
Okay. Okay, that's
yes,
good to hear
because
yeah, this is the nature of the self-assessment, that you're never sure what comes around the corner and the next day, basically. Yeah.
Yeah, that's true. And I think, for example, with cellulose, it would be a totally different story because so many questions pop up. And in this case, it's really the production method that makes it relatively easy. Because in theory, and then you can analyze it, and the analysis confirm the theory, that the filter stops so many of the contaminants. And we had an external party checking it. So that felt, so consultancy. So that felt also very nice to have that checked.
Okay, thank you.
Good. Yeah, I also have a question, Emma. Regarding like selling this product to other countries, how I don't know if it's in your plans, or how do you deal with this? Is it possible, like doing a self-assessment in another country, or is how do you deal with this international approach?
Yes, we don't have those plans yet. And if we will, I think it really depends on the country. Because it's a self-assessment, it doesn't go abroad, right? So we have to check if the other country accepts our self-assessment and sees it as end of waste. And we don't have any plans for that at the moment.
Okay, thank you. So thanks a lot, Emma, for your. There is one more question in the chat. Is the end of waste status now applicable to different plants utilizing the same production technology, or is it plant specific?
It is plant specific, but since you already have all the theory written out, it's basically doing the analysis on the other plants. If the production technology is the same, and if the analysis status that it works the same and you don't find anything like you would expect, then you can just add that to your self-assessment.
Okay, I think it's clear. Okay, thank you, Emma. Yeah, also thank you from the Maria Valtari who posed the question. So we are then moving forward to the last but not least presentation from our colleague at KWB. It's Christian Remy, also partners in the Boosting project. So Christian, the floor is yours. You will, explain us also the idea is also to discuss the way forward. So this presentation is also a call for action for everybody to see how we advance. Yeah, we can see your
Thank you,
screen
Rafa.
perfectly.
Thank you. Yes, I try to wrap up a bit what we learned so far and see how we can move forward. So my name is Christian Remy. I'm coming from Kompetenzzentrum Wasser Berlin, and I'm part of this Boost-in project, which was mentioned before by Rafa, and which is a co-organizer of this webinar. And there, in this project, I'm responsible for this end of waste task, basically. So what did we learn today and before, and what can we do, actually? This is a bit the content of my presentation. So the big question that we started with the project was a request to harmonize this end of waste criteria thing. We see that there's lots of problems on the ground to get end of waste for materials that are new, that are not defined yet. So the Commission asked also in the call for the proposal to work towards harmonization of these criteria on European level. And the first thing that we learned is that there is, of course, a process for European harmonization of end of waste criteria, but it involves an extensive stakeholder consultation process, and it's typically led by the Joint Research Center. So the Center of the European Commission working on, or scientifically doing a support for the Commission. So it's a long process. And what we also learned is that they did a scoping study some years ago to check which type of products are good or are at which state of the market for European harmonization of this end of waste criteria. And on the right side, you see a glimpse of this report, and you see a kind of a priority list. And well, the bad news is water products or water-related products had a low priority in this list. They are tagged here in red, and you can see that they are more or less on the lower end of the priority list. And so the work of JRC actually would focus as a first step on these green streams over here. So we learned, okay, it's a long process that it takes, and at the moment it's not foreseen that, let's say in the coming years, JRC will start this process. There is one slide that I want to show about this European harmonization. I know that Lukas Egle, I lended this slide from him. He's in here in the webinar, so maybe he can say a few words on this later on. But this route to European harmonization is called the Sevilla process, and it's a participatory stakeholder process, which is moderated by JRC, and which, as you see here, some kind of timeline, involves, of course, a kickoff, certain workshops, data collection, feedbacks, and certain action steps. And the main thing is that it typically takes a few years, let's say, and it results not in a binding proposal, but it's only a non-binding technical proposal, which has then to be adopted in the policy context. So this is the true road to European harmonization. So what we learned in the project is it's not feasible for us in the project to follow this process. It will be moderated by GRC officially, and it takes a lot of stakeholder involvement. Okay, so we learned, okay, European harmonization, let's say, is far away than we hoped for. So it's a long road. And nevertheless, we learned in our workshops that we had so far, and Rafa mentioned some of them in the beginning, European harmonization is difficult, but, and as we saw also today, different other routes are, of course, possible to achieve end of waste. We saw national rules, we saw self-assessments, we saw case by case, we saw even legal opinions or others. So there is hope, let's say, that end of waste can be reached, but it takes a lot of work and effort for stakeholders on the ground to do this. And so this brings me to the next point. We identified a big need within the group of people working on this to connect and to exchange experiences, what is working, what is not working, what are the problems, and to learn from each other. And we also mentioned, we also managed to raise interest actually of DG Environment. The colleague responsible for this topic was invited today. Unfortunately, she's not able to attend, but she's interested in this topic, and they also see the problems of the water sector to move forward here. And we also have the JRC, and I think Lukas is here today. So they are interested also to see what we're doing and to participate. And if you're interested in our, let's say, more details of this outcome, you are free to access our report, a bit of the state of play of end of waste in the water sector, which is available online. So what is possible today then? So what can we do? We see that these different routes are available. So I think the main thing, and that's also the sense a bit of today's webinar, is to learn from each other, to learn who is active in this field, who is trying to get end of waste for which kind of product, in which type of route actually. So either national rules, self-assessments, whatever there is. So to exchange, to learn from each other, and to join forces and to try to tackle this together. Because as a single company or as a single player here, it's very difficult as we learn to reach end of waste for any type of new material. In terms of European harmonization, what can we do? We see that we have still, or at the moment, a low priority for this European process. But again, we can start it. We can collect data for new products. As we saw today, we can propose some end of waste criteria for specific uses, for specific products, and make some pre-work or preparatory work when future harmonization will start. And this is something that we will try until the end of the project now, which is ending end of this year. And we try to produce a report where we make this exercise for a selection of products and try to bring forward some data, some specific criteria, and propose these to basically pave the way for future European harmonization. And the last thing that we learned is we want to establish a network, something like a group of people who meet regularly and to exchange on this end of waste challenge, because we see that it is needed, that people can benefit from it, to learn also what is going on in the different countries. And I come back to the report of Christina and of the CIRSO project, who checked in the different countries what is the situation, and we see it's quite different between the countries. So I think it would be good to exchange and to see what is possible where, and also to learn from each other, and even involve authorities who are basically at the other side of the end of waste criteria, and try to involve them also in this process. So, how to? So, what is this expert network then about? And so, our goal will be really to connect stakeholders, expert stakeholders who are working on end of waste applications. And we, at the moment, we foresee that it could be regular online meetings, a bit like today, but probably more focusing on an interactive exchange on cases, maybe 2 times a year or so. So, to have regular online meetings on this topic, and maybe even have a point online where we have some knowledge to be placed, some slides, some dossiers or whatever, so that people can access information on this end of waste. Because at the moment, if you look around on end of waste, there's nothing basically to be found, and you really have to chase and to search for people who are working on this, because it's not something that you find in the public sphere. So our to-do at the moment is really to find a suitable platform for hosting this expert network that we want to initiate, and probably to find also and to define a bit of a lead organizing team which drives it forward. We also wanted to inform DG Environment, and this would be also the sense of today, but I think Rafael mentioned it, that we will follow up with them and explain the outcomes of today's webinar, and also express the needs of the sector, that we still have this challenge, that people are putting a lot of effort in it, but it's still difficult to move. And we want circular economy. There's a Circular Economy Act coming up, as we heard. And so we need to, again, make ourselves heard and express the need of the sector to connect and to have such a network, so that people can at least learn from each other and try to move forward together, and not so singular as at the moment. So my last slide of this presentation brings me to back to our questionnaire, which some of you may know. So we have an online questionnaire, and maybe Rafa, you can put the link here in the chat, so that people can raise their interest to join this task force, it's called here, but I would also call it network. So to join this group of people who are working here, who are exchanging here, and who want to bring forward this end of waste, or who try to attack and let's say overcome this end of waste barrier that is still there. So this is a bit my last slide, and the next would be a bit an open discussion and reflection on this networking idea. And probably before we move to the big audience, I would take the opportunity to address our speakers from today. And I probably want to hear from Sarah from Easy Mining. How do you feel it? Do you know a lot of other companies and people who are working on end of waste, or are you feeling lonely a bit? I was wondering, because you have this Nordic perspective, and still you have quite a big company in the background. How do you see this need? Do you see that this would be meaningful to have this network of end of waste in Europe?
Yes, definitely. I think it would be great. I think we have very different challenges, though, so I think it should be quite big, hopefully, so you can find someone with similar problems, because some materials, they are more complex in the seizing of being a waste. There's no clear criteria, or you don't fit into the FPR, for example, you're still not in there, and those discussions are one thing. I think our problems are a bit of a different kind, where you have kind of more pure chemicals, monoconstituents, as I said, but those come with other issues that you want to discuss maybe. So it's good if it's a big network with all these different types of materials, if it's an article, or if it's a substance, and what type of substance. Even those details make difference here in the discussions, but of course also what applications you're going for. And also it's good to discuss within countries, even, I think, to find friends in the same country, because maybe you can then go together to get the national and the waste criteria. In Sweden, for example, we don't have a fertilizer legislation. which makes it super tricky because then we only have cadmium limits for fertilizers as an example, and then it gets super tricky. Like what should you fulfill? You have to make everything up yourself, which is of course horrible. You could look at the FPR, but yeah.
Mm. Okay, and do you know any other companies who are actually trying to get end of waste for any water-related products?
Yeah, of course. I mean, there's a bunch of them who wants to do biochar. I think that's kind of big, as an example. So sure.
Okay.
There's different producers or who wants to do lime recycling into the fertilizer business. I think that has a problem there to find the right quality in Sweden.
Okay, yeah, thank you. And maybe over to you, Alke, and then the Dutch case. So you initiated also this idea of exchange, and maybe you can say a few words on your perspective. And we also try to search around, even in the European sphere, to find companies, and there don't seem to be many at the moment because probably most are reluctant to go down this route. How do you think? Yeah.
Yeah, we have a strong network in the Netherlands, in which we are in kind of in the middle, if it's about end of waste. But I would really like to exchange experiences with similar cases in other countries. And also, for us, the main topic is, of course, the contaminants in the fourth end of waste criteria. But I also recognize the questions around REACH and around other topics around regulations that don't allow the use of secondary materials yet, which makes it impossible to get end of waste. So yeah, I would really like too much an European network to come to life.
Yeah,
In which we can help each other forward. Yeah.
Yeah, because I see that actually you're in Dutch. As you said, in the Netherlands, you're very active and you try different routes, the national regulation and also others. Maybe Sarah, yeah, you can comment on it directly.
Just a short comment. I mean, we talked to the Swedish EPA and the Chemical Agency, and one of the most popular questions that they get from companies is coupled to end of waste. So there has to be a lot of companies who is struggling with this since they are complaining that there's too many end of waste questions. Obviously, you don't have like a list of all the ones asking these questions, so you can just share them. But maybe if you could bring some EPAs into the network, you would also that would be smart, of course, because and I heard a comment earlier that the knowledge about these questions from the municipalities, the county boards, even the Swedish EPA, I can say, I hope no one will kill me after this, but the knowledge is sometimes kind of low, and that is of course a problem.
Yeah, thank you. It's a very important point to involve also the other side, basically. So the authorities that can have to grant end of waste at the end in this exchange, because they are also feeling lonely probably somehow, challenging tackling new products and new regulations without enough efforts or enough resources, actually. Sorry. Rafa, please, and another one.
Yeah, I just wanted to say that one of the goals is to advance end of waste and avoid this fragmentation that it's now limited to cases which are more focused on the national landscape. So we want to exchange, and I would like to open the floor today also for our participants if they want to share any particular case or experience with end of waste. Yeah, you can fill in this form that I shared in the chat, but also you can raise your hand, and I can give you the floor to introduce your case, so we can also be aware, because it's one of the challenges that we are experiencing, as said by my colleagues, to get to know real cases in end of waste in the water sector.
Okay, thank you, Rafa. Maybe Christina, you from the CIRSO project, you made this review, as you said recently, about the country situation. Did you come across real companies or people trying to get end of waste in their national circumstances, or do you have how's your feeling on this?
Yes, well, as I said, we did the interviews with different types of stakeholders, and I can only confirm what the speakers before said. So the companies that we interviewed, they raised this issue of not having the direct competent partner also on an administrative level to discuss these topics. And from the more administrative or water association side, it was also increased this stressed this point about having this exchange among the different stakeholders due to this fact that there's no one who can really tell you this is right, this is wrong. So I think it's really a matter of peer learning. So therefore, I would strongly encourage everybody to join to answer this questionnaire, because I think it's a great initiative.
Yeah, thank you. Peer learning is a good keyword, actually. So we have to help ourselves in times of uncertainty. There's one question in the chat, but I'm not clear. Rafa, can you see it? I don't have it. I just saw it.
Yeah, there is a comment from Renata. So asking if we have an idea for products from waste streams that are allowed, would that be the products that are the best to reach circularity? It seems that she has a company. She has the contact of a company making keychain hangers from a waste stream. How many do we need? So I understand, Renata, that you have contacts of a real case that you would like to share with us. So feel free. Yeah, we need as many as possible, and but anyone will be valuable. So any contribution you can do, it will be great. If there's anything else you want to share with us, just raise your hand, and I can give you the floor.
Okay,
I
and
see.
maybe exploring a bit this platform
One
thinking.
second.
Yeah, is there a okay? Do you want to open the mic?
Yeah.
Yeah, it's just a short question. So I don't know if I should mention the name of the company. They are almost completely circular, and they have one waste stream which is mostly organic, but it's small, and that's why my previous question related to that as well. What do you do with these small waste streams? And so they decided to make keychain hangers and some small pots, but there's no real business case. And so I'm wondering, we are now looking for products or uses that are allowed by the European Union. But are these the ones that eventually lead to a circular economy? And I don't expect you to know the answer. I'm just wondering, is there like an overall picture of what we're doing with all these waste streams? And trying to prevent that it's waste, and but does it really promote circularity? That's basically my question. I'm just wondering what your thoughts are on that.
Yeah, it's more philosophical question, I would say, but very good actually. So what about all these small things? I mean, in the wastewater, we heard also that the volumes are low. We are kind of addressing niche markets sometimes, so we're not the big players, but still it could be a route to circularity. And end of waste is really a specific barrier for all these small little streams that fall apart here and there, and they want to go circular, but yeah, they are still on the waste regime, and so there's no business to be made. I don't know, Alke, how do you see it? I mean, you're also working with several locations with small volumes. It's difficult. I mean, you have to bring them together to have a critical mass for any kind of this route, these regulations.
Was this a question to me, Christian? Sorry.
Well, I
Yeah.
was because Aquaminerals is
Yeah.
a bit collecting these kind of small volume things, and I think the meaning of Aquaminerals was really to have a
Yeah.
more market power and organization behind all these small production.
Absolutely, but I think the question was more about this. Was it about small waste streams that don't have any other applications yet? And if it's a used for application, well, it's a start, eh? you can also always grow into something more useful, something bigger. A lot of things start in some niche and then get traction and get into another niche and then grow maybe later inside of a bulk market.
Yeah, thank you. Sarah and Emma, you are also putting your hand.
Yeah, I had another comment, maybe also for a forum like this. I think it would be very useful for a lot of companies to get if they need help, like not just to discuss, but maybe to make the documentations or to get the right analysis, like we have had problems with. It's great if you can have recommendations on what consultants you can use that have been doing this before and that are good, and not just saying, yeah, we can do this, and then it's just a lot of hours and cost. I've tried both ways, and I think so that was something I would at least have appreciated a lot, that someone would tell me for those questions, if you can buy some hours of this consultant, those are really good consultants in this area. That's also very helpful. Sometimes you don't have enough time or competence yourself, and you need an expert, and that's great to get, I think.
Yeah, this could also be one sense of this network to exchange on whom to approach, actually. So Emma, please.
Yeah, I thought with regard to the question that was just asked, I think I see a lot that we're having uses that are more of lower quality, so to say. For example, cellulose you can use in a road. Well, maybe you can have use it as isolation material as well. So that the question, like, what are the uses for circular economy? The role they can play is that often you start very risk averse, right? But if we trust more the method that we use to do a risk assessment, it may be easier to go quicker up the ladder to use more really useful applications for your materials.
So you mean to start with a low dangerous use and then move
Yeah,
up the ladder?
exactly. I see now often that companies think like we use it for something which has no risk whatsoever, then it's safe. But there are actually more useful ways to use it. But that means that you need more trust that your risk assessment is either very solid or that it's accepted by governmental institutions. Or so yeah, I think if we have more trust in the methods that we use for risk analysis, we can move up quicker on the ladder of useful applications. Yeah.
Yeah, it's a good point. Good point. So the risk assessment is really, I think, a key question on this challenge of end of waste. Ake.
Yeah, not only from a safety perspective for human and the environment, but also with new resources. We also start with customers that are relatively easy. They don't require that it's always available. They don't require small volumes. And for them, it's kind of nice to have. And they pay a low price, but you need that to get you need first experience to get a stable value chain. You have to be sure that that the recovery operation is working always and trustable, and that and the larger the volume, the easier you can guarantee that. If you have multiple producers, it's easier to guarantee. So what we see in our practice, we start often small with one low value application and then move upward.
Yeah, good point. So you get more safety when you have a bigger bulk of things that you can mix, actually. Yeah. Interesting. I'm a bit so the network, I think, is now clear that people would like to connect and exchange on procedures, risk assessment, and also people who to approach probably, and who is experts in this field of not only probably consultant, but are also thinking on labs and lab analysis. We heard from Alka that it could be a problem to find a lab that is that can tackle actually what I want. I'm wondering a bit about these criteria and the preparatory work that we could do, or really propose criteria. How do you see this when you prepare this criteria? You put a lot of effort, you put money in it, then you have a dossier. Is it something to be shared publicly, or do you see that as a competitive advantage to have this end of ways and others may not have it? How is the situation with sharing of this information, both from Aqua Minerals and also from Easy Mining, probably? Emma, please.
I think it's very important to share. Yes. So I think as much as we can share without that it's really like private information or business information, but we should share the methods that we choose. So we can learn from each other. And also the idea that if we collectively get better at this or use certain methods, it becomes more and more solid as well.
Yeah, and the work that we do for the cellulose project will anyways be public because it's a project together with the government. They will publish all the documents, so that's going to be available. Maybe in Dutch, but well, there's Google Translator or whatever. Yeah.
Okay. Yeah, I understand that you cannot share sensitive information, of course. If there's analytics from certain production places and sampling data, it could be sensitive. But I also am thinking in this direction of EMMA methods and also probably contamination levels that are acceptable for a certain stream. I mean, this is also something that comes back from the authority to say, okay, this is okay, this is not okay. So this threshold level that needs to be established. This is a critical point, I think, and which substances to analyze. And this could be information that is non-sensitive, basically, which makes sense for everybody to be there.
Yeah, definitely. And if there are no regulations, it's also very hard to find like what sometimes I don't know the English words, but like what limits you want to use. And yeah, it would be very useful to share them so you can pick up ideas on how to do that. Because for some applications, there are very clear regulations, but for others, they're not. So like how to handle those is also good to share, I think. Yeah.
Yeah, this whole bunch of emerging substances or new pollutants that are out there and also in the wastewater.
Yes.
Yeah.
Yeah.
Okay, looking at the time, I think we are almost done. I don't know, Rafa, do you want to make a wrap up and a round up? So finish the
Well,
webinar then.
you're right. We're getting to the end. First, thank you everyone, all the panelists, all the participants for this. I think, we have learned a lot today. We can see that harmonized end of waste criteria is really challenge and a complex process. Even these experiences at national level are also complex, and that's why I think this type of events are useful because we can learn from each other. So hopefully we can continue this work in boosting and probably beyond. I also want to thank Water Europe because they give us the platform to reach more people and to put all these issues in the table and to have this discussion and to reach experts who may have addressing the same problem. So I want to give my true thanks to the Water Europe team. I don't know, Andrea, if you also want to say some words to conclude this webinar.
Thank you, Rafael. Thank you so much. I mean, and thank you for the great effort that the expert group, the Boosting and the CIRSO project, and all the speakers today made for make this this webinar more than interesting, but really challenging from many angles. Because I would say that my intention was, I mean, to speak about, I mean, the main key messages, but there are so many. Also because the topic is quite complex. I mean, it touches, I mean, regulatory approach, it touches, I mean, technology, it concerns, I mean, the capacity of the member state, the European Union, to find, I mean, a common understanding on even what is, I mean, the end of waste concept. So I think that the efforts and the challenge is really great. But nevertheless, I mean, I think this webinar is a milestone. Because we had also the contribution from two key projects, I mean, the boosting and the CITSO, and of course the expert group and the other experts, I mean, and the other organization that provide, I mean, their contribution. Is a milestone because, I mean, I think that there are few opportunities like this, I mean, really to have such a pool of knowledge and capacity of analyzing the problem from its deepest roots, I mean, in Europe. So a big thank you for the webinar. A big thank to all the speakers and also to my colleagues in Water Europe that supported the implementation and the organization of this webinar. I pass you the floor once again for the final words. And once again, thank you so much from Water Europe and from Water Europe community for this great webinar. Thank you.
Thank you, Andrea. Yes, I agree. This has been also a milestone for us in the boosting project to gather this experience and to be able to share with the water community. Just a final reminder: you have in the chat this Google Forms to collect interest and to keep building up this community. If you have interest, it's a very short questionnaire just to see your level of experience and if you have interest or not, and to keep you in the loop. Yeah, I really appreciate this opportunity. Yeah, we keep in touch. So, bye bye.
Thank you.
Thank you.
Bye bye.
Bye. Bye.
Bye bye. Thank you.
Yeah, thank you.